Hi everyone. In this other video, I will be explaining how to determine the component of a vector. But in this case, if you have watched the first video, which is the part 1, I focus only on the angle of inclination to the horizontal. But you can also use the angle of inclination to the vertical to determine the component of a vector. So in this video, I'm going to be showing you how to determine the component of a vector when the angle of inclination is to the vertical. So how do we do it? Now let's assume we have a vector like this, and this vector, in this case, this vector is still a force vector, and this is your y and this is your what, x component. But in this case, your angle of inclination here, let me call it alpha, is inclined to the vertical. Now we want to determine the component. Like from the definition I made the previous video, I said the component of a vector basically is the effective value of that vector in any given direction. For example, if a boxer is fighting, for those of us that watch boxing, there's what we call straight blow, there's what we call uppercut. Now straight blow basically is the horizontal component of the force that the boxer is applying to the opponent, while the uppercut, is the what, vertical component, meaning that is, so now what would be the effect of that force in those two directions? So the angle of inclination will actually determine the magnitude or the effect of that vector. Now in this case, we have our angle of inclination to the vertical. Most of the time I do tell my student to always make it to be inclined to the horizontal, just for the purpose of consistency. How do I mean? If you have the angle of inclination to be to the horizontal, we already know that the vertical component is what, f sine what theta, while the horizontal component is f cos what theta. But if it is inclined to the vertical, in this case where we use our theta to be angle of inclination to be alpha, then it will be opposite of each other. So let's quickly go straight to that resolution. So let's start with the vertical component. So in this case, the vertical component comprise of what? Okay, let me resolve this. So if this is our alpha, then I can complete this triangle like this. So this is 90 degrees. So definitely this is hypotenuse. If alpha is our reference angle, definitely this is opposite. And of course, this other side is the what, adjacent. All right. So this is our reference angle. Well, of course, I can use this other side too. The only difference is that I will have to incline it to this other side, just like the previous video. So for the vertical component, we are considering now the vertical force. So the vertical component will be somewhere here, that is f subscript y, while the horizontal component will be here, that is f subscript what, x. So the vertical component will now be the force and its effective value in the y direction, and f subscript y. All right. So now if you look at this, if this is our reference angle, that means we are considering adjacent, which is f subscript y, and the force, which is the hypotenuse. And adjacent over hypotenuse is what, k, which is what, cos what, alpha in this case is adjacent, which is what, f subscript y, divided by what, f, which is the what, hypotenuse. So if you cross multiply, we have f subscript y, we now have a what, f what, cos what, alpha. So this is the vertical component of a vector, if and only if it is inclined to the vertical. All right, so let's consider the horizontal component. So here we have the what, horizontal component. So for the horizontal component, we have what, f and what, f subscript x. So this is the horizontal, and it's also the same thing as horizontal component, especially if you complete this triangle here. This alpha will also be here. That's alternate angle, right? But I just want to maintain this upper part just for consistency sake and not to make it complicated. Okay, so now our f subscript s is opposite and our f is hypotenuse. That is opposite and hypotenuse. That is so. So we have what, so, which is got to what, sine what, alpha is got to what, opposite, that is f subscript x, over what, hypotenuse, that is what, f. So if we cross multiply, then it implies that we have what, f subscript x is got to what, f what, sine what, alpha. So this gives us the what? Horizontal component. So there's something I want you to know. Note this, right? Note this, that if the angle, right, is what? Inclined to the what? To the vertical, right? Then f subscript what? Y is equal to what? F what? Cos what? Cos alpha. In this case, the angle is alpha. And what? And f subscript x is equal to what? F sine what? Alpha. That's number one. Then number two, if the what? If the angle is what? Inclined, right, to the what? Horizontal. When I say horizontal, in this case, let me just put something here. Let's say this is what? Theta, right? If the angle is inclined to the horizontal, then we have what? F subscript y to be equal to what? F sine what? Theta. And what? And f subscript x is equal to what? F what? Cos theta. Now, please note something. Both theta and alpha are just dummy variable that represent angle. I only use alpha and theta to show that alpha represent angle of inclination to the vertical and theta represent angle of inclination, to the horizontal. I want to believe that this video has helped someone. Please kindly subscribe, share, and like this video. And if you feel this video has been a source of tremendous help to you and you want to support what we do, please kindly check the description for the necessary details on how to support us. We'll be looking forward to receiving from you. See you in the next video. Thank you.